Hello everyone, welcome back to my math channel online today. In this video today, I would like to share with you about the sketching the exponential function in the course of Math 12 Calculus. Like any other graphs or on any other function, normally, we would sketch the function by plotting a couple of points on the graph. And we use a data table based on the function. We plug in some independent x variable and calculate the y, which is dependent variables, and plot some points. However, doing that will be a tedious task and it seems not convenient. So we use a graphing calculator for convenience. However, if we be able to analyze and identify some special characteristic of the function in math, then we don't need to use a graphing calculator. And my philosophy in math teaching is I tend to use a graphing calculator for checking our errors and our accuracy, but not for replacing by using the graphing calculator. Because I don't believe in technology can replace the mathematics concept. So let's talk about the mathematics concept so that we can sketch any function based on their special characteristic in an easy way without using the calculator. Like any function, I would like to start at the basic function. So you know that for the exponential function, the basic one will start from y equal 2 to power x. And the reason, because the base here, the minimum number have to be start from 2. If we start from 1 to any power is just 1. And therefore, we know that the base here have to be different number other than 1, number 1. So it could be 2, could be 3 or 5 or 10, or even the minus, but not 1. Second, what do we notice? We also noted that because this is the exponential growth, so if the x getting very large, this way, let's say positive infinity, then of course, 2 to any power will be grow very quick. And therefore, the function will have a shape of growing like this. As x getting large this way, the y will getting large that way. So that is how we know the shape of the function. What else do we know? We also know a couple of points easily. If we put x is 0, then doesn't matter what base is here. The base can be 2 or 3 or 4, but any base to power 0 is equal 1. So therefore, we know the function have to go to the point of 0 for x and 1 for y, regardless any base. So by doing that, we also be able to sketch the graph easily. Now, let's talk about if the x is a very large negative number, what happens? Then your y will be equal some kind of form of negative x number on the top. It means we can bring this become a fraction, we can bring it down and change x to a positive. So it means if x equal 1, then y will be equal 0.5 or half. And this fraction will getting tiny and tiny, as well as the x getting very large, negative infinity up to here, then it could be 1 divided by a million or something. So it means that the y will become a very tiny fraction, but never equal 0. We will have 0.0001 or something, but it never touched the 0. because the y will approach that way. So therefore, we can know that the axis here turn out to be at the y equals 0, the function never touches and become an asymptote of our exponential basic function. And therefore, I put dotted represent for the asymptote. So we have an asymptote at the axis here. And we know the function will get very close to this asymptote, but never touch it, and will be getting big a little bit when it goes to 0 and across the number 1 here. And let's put a couple of points. If x equals 1, y will be 2. So we go through that point. If x is 2, y will be 4. So we go through this point. So this is the shape of our basic graph. Will be like that. Now, I put the dotted because we don't want to get this basic, right? We want to guess the first number, which is y equals 3 to the power x plus 2 minus 3. So, based on the spatial characteristic like that, we'll be able to sketch any transformation of our exponential function easily without graphing calculator. So let's do that. Let me remind you a little bit about the transformation, right? Like any other number, you know that if you have a number adding to the x or subtract from the exponent here, it means that function will move to left or right by 2 units. And this we call an h value, right? H value. And this number we call a k value. So the h here equal 2, it means we move the graph to the left by 2 units because the sign is positive. So positive, we move to the left. If it's negative, we move to the right. In terms of the k value, it means the vertical shift up or down. If it's negative, we shift down by 3 units. If it's positive, we shift up 3 units. So look at this function. We know the function will shift down by 3 units. It means any point on this basic graph will shift down by 3 units. So let's pick the point, pencil here, 1. And using this transportation. Now the base doesn't make the shape different very much because this base here is 2, this base here is 3. It's just one number. However, we know that if the base is 5 or 6 or 3, the graph going to go through number 1 anyway. So let's base on this number. And let me talk a little bit about the base a little bit. Now we also realize if this base is big, right, it means that the graph will roll more intensively, increasing in a very rapid fashion, right? So if this base is getting large, the y even though getting higher and higher. Therefore, as long as you have a base bigger than this, then the shape will have a steeper slope and move towards the y-axis. So let's say if you have a base 10, then your shape of this graph will closer and closer to the y-axis because the slope will increasing in a rapid way. And therefore, it's getting closer, steeper and closer to the y-axis. So that is about the base. So this base is not much different, but we know that it will get inside a little bit like that, right, for the base. However, the number 1 here will shift down by 3 units, 1, 2, 3. So the number 1 here will shift down by 1, 2, 3, and move to the left by 2 units, 1, 2. So this point here will become this point here. We can mark this point -2 for x and -2 for y. What else we also notice? the horizontal asymptote is a very special case for exponential. So if you look at this number, you know that we will have a horizontal asymptote y equal minus 3, because this horizontal asymptote of the line x here will move, axis here will move down by 3 units. So we'll move 1, 2, 3. And therefore, we can plot the horizontal asymptote as well. So our horizontal asymptote will move down by 3 units. Let's tie down one more point, we'll be able to sketch the strap. So we have one point here already. If x is 0, let's set x is 0, what y equal? Y equal 3 to the power 2, which is 9. 9 minus 3 is 6. So we know our y-intercept will be there. And x is 0, y is 6. So at this time, we'll be able to sketch the function easily by shaping it along with the asymptote and go to this point. And not doing a good job, sorry about this. So here's 6. So it looks like something like this. So that's our new function. That is a transformation of our exponential function to this point and keep going like that. So we're done with the first draft, and you see that we don't need the calculator, drafting calculator. Okay, now let's talk about this draft here, down here, and see what is the transformation for the second draft here. So we have a base of a fraction 1 over 3. However, we also can rewrite this as, if I want to bring the 3 up here, then I have to twist the x positive become a negative. And everything else is the same. And that's the law of exponent, right? When you change the position of numerator and denominator, you have to twist the power to the opposite side, and that's the rule. So let's find out what happened to the graph. So this graph have a negative x, and make sure you know this form and this form is the same, right? So we have a negative x, it means we have a reflection over the y-axis. So our graph, instead of going this way, now we'll go the other way, like this. So this is reflection over the y-axis. What else do we notice about that? We also notice that our horizontal shift, right, instead of 0, now it will shift up to vertical shift, will shift up by 2 units. So I'm going to mark the horizontal shift here. We shift up by 2 units. And that's our new horizontal shift. And instead of the wrap across number 1 right here, now we shift up by 2 as well. 1, 2. So this is 2. So this will be 0 and 3. Now we don't have any translation to left or right. So this point will move up here. And it will reflection over the y, so we shape this way. But let's see how we calculate the y value. So if let's get things very large to negative infinity. Let's say x equal -3. Then what is y equal? Y will be equal 3 to the power of negative times -3 plus 2. So this will become 2 negative will make up a positive. So will become 3 to the power positive 3 at 2, which is 27 at 2 is 29. So if x is -3 this way, y up here, 29, somewhere up top here. So we see that, yes, the shape is accurate. So let me move this closer so we can sketch this. So our graph will look something like this shape and get along to the asymptote here and have a shape look like this, going through this point, 0, and 3. So that's how we sketch the second graph. So now let me show you how we sketch the third graph. Now, if you notice the third graph have a negative in front of function, that tells us this is the reflection over the x-axis. It means if we have a graph original like this, now reflection over the x-axis, it will go like this. It will go this way because of this negative here. So now let's make more observation. We also have a horizontal shift to the right by 4 units, vertical shift up by 5 units. So this is 0, the horizontal asymptote will shift up here, and therefore I sketch this horizontal asymptote. Here is 5 units. So I scale 5 for each unit. So this is -5, this is +5, -5, -10. Okay, so now we know the graph will look like that. Let's imagine if we have a point across 1, we'll shift up to 5, so then it will become 6. However, because of the reflection, so instead of go up here, we will go down here. And because this point will reflect down here because we reflect over the x-axis or the horizontal asymptote. So 1 shift to 5 becomes 6, reflect back down here because of this negative. Also shift to the right 4 units. So that point will become this point. And that will be 4 for x and 4 for y. So now we know that our shape will look like this, go across this point, and we'll go across this point and keep going like this. So that's how we sketch the third graph, how it looked like. So you can see that it's how easily we sketch by hand rather than graphing calculator. It takes longer. Now let me try to enter to the calculator and see what happens. So let's say I have function. I'm going to check one calculator, okay? So I'm going to say y equal -3. And then power bracket x -4, close bracket, and +5. So I key in the equation look like this. I hope you can see it, right? And I'm going to enter. And this is how the graph look like. So the direction exactly the way we sketch on the board, except the scale is not even as pretty as the way we use a hand sketching, because we can scale the unit probably, right? So today's lesson is on about the graph. However, I want to make one more point in this lesson today for my math courses online and for those students who enroll in my math course to learn the full lesson. Before I move on, for the next lesson will be about the application of exponential function in finance and in any other science as well. But first, I will talk about the finance first. So stay tuned for the next interesting lesson about the application of this exponent in finance. But before I end this video today, I would like to show you one more point. I want to give informative, sufficient information for my math courses online. So I toss in one question in this lesson of sketching. Add one more section in this lesson, by the way, because I want to finish this for the lesson for my math courses online. For any student who register to my math courses online to learn about this. Then I don't have to do another video. My next video will be about the application of the exponential function in finance. So that will be more interesting. So this is the little point I want to touch in this lesson, which is giving you the question like this: find the base if y equal b to the x. That contains the given point 3/2 and comma 27. So if they give you a point on the graph, you see x and y coordinate. All what you have to do is substitute the x into the value here and y into the value here and solve for the unknown equation. And I believe that question 4, you'll be able to do that, no problem. So I'm going to show you question 5 because this is a long video already. So let's say find the exponential function in the form y equals c times 2 to power kx. Passes through this point 0, 4, passes through 0, 4 and 12, comma 2, 5, 6. So how are we going to do this question? How are we going to answer this? Now notice this is the coordinate x and y, right, for each point. So all we do is let's substitute into the equation. We have the equation y equals c 2 to the k of x. So how many unknown we have to find? We have to find what the c here and what the k here. So let's take advantage of the coordinate 0 for x and 4 for y. So we'll substitute the y here is 4. And I'm going to substitute the x here is 0. And 0 times with k will become 0 on the top. It means 2 to the power 0 will be 1. 1 times with c is c. So it turns out c will be equal 4. So now we know that we will substitute back c into the equation, which is 4 times 2 to the k of x. And now we can use another point and solve for k. So if y equals 12, c will be 4 and 2 and k, just k we're going to find out, and x will be 12. So we have an equation, y equal to 56. Sorry, it's my mistake. So y is 256 and x is 12. So now if these two numbers multiply together, so all what you do is divide both sides by 4, you'll be able to cancel the 4 here, and 256 divided by 4 is 64. 64 will be equal to the 12k. Now, by doing this, I noticed that 2 to 5 equals 32. And 2 to the power 6 equals 64. So if this right side equals this left side, it means the power up here, 12k, has to be equal number 6, so that you can have a 64 like that. So now divide both sides by 12. The k will be equal 1/2. And now you will look back in the equation and write down. So we have the equation y equal c, which is 4, the b is 2, and the k is 1/2. So 1/2 x. And that is the answer when you answer this kind of question for our number 5. So this is a long video. I'm going to have to end it here. And thank you for watching. We'll see you in the next lesson. Bye for now.